All right, let's keep rocking here. Section 4 is talking about coal. What's good and bad about that stuff? Ooh. So, coal, as a Wyomingite, are intricately aware of coal and its benefits and drawbacks, I'm sure. Some pictures for you. This is old school underground coal mining out in West Virginia, but this is a common occurrence to see around the state of Wyoming. We ship out hundreds and hundreds of cars of coal a day. So, what is coal? It is solid fossil fuel, basically. Okay, it comes in different stages of quality, but it came from basically the remains of plants that lived about 300, 400 million years ago. So it's very old. It's basically compressed plant matter. We use it for mainly electricity here in the United States. You see that 49% of U.S.'s electricity comes from it. Here in Wyoming, it's 90%. We use a lot of coal here to power things. We have 2,100 power plants around the United States. The coal in Wyoming gets shipped to Tennessee, all kinds of different locations. And so it is a big source of electricity all the way around. What's the problem with that? Well, that process of creating electricity from the bringing of coal isn't necessarily the most efficient process. There's a lot of energy waste in that process, so we need to improve that facet a little bit. So how do you make coal? Well, coal starts as this dead plant material, 300 miles you go in the swamp. The material dies and settles to the bottom, gets buried with dirt, sometimes covered with water. It gets pushed under the ground deeper and deeper until it gets made into coal. And the way it gets made into coal is basically two things. It's put under heat and pressure, and it is basically squeezing out moisture content. So the less moisture content and the more heat and pressure it's under, the more high-grade coal you get. So peat is not coal, but it's the starting dead plant material that we begin with. So way back in this stage, this would be peat. So it's semi-decayed, swampy, boggy, schmutzy stuff. You start putting that under heat and pressure, you start squeezing out water, and you create what we call lignite coal, also known as brown coal. This is not very good coal. It doesn't burn very hot. You don't get a lot of energy output out of it. It's not super great. You then put more heat and pressure under the system, and as you do more heat and pressure, you squeeze out more of that water, and you create what we call, actually there's two categories here, subbituminous and bituminous coal, but they're both, bituminous coal is what we call soft coal. It has quite a bit more hot energy yield than the lignite coal does, but it's still fairly high in sulfur, which means it is a much more of a polluter than some other coal things. So it's a good mid-range coal. This is what we have mostly in Wyoming, is just this bituminous coal. If you put coal under enough heat and pressure, though, it creates what we call anthracite coal, which is really hard, dense coal. This is the best kind of coal you can get. It has the highest energy content yield out of it. It burns the purest of all of them, but it is in very limited locations and it's used up rapidly. So it is not our main source. It is highly coveted coal. When we burn coal power plants, it's a pretty basic system. Coal gets crushed, pulverized down here into this system. So there's a big hopper full of coal that then gets crushed in, turned into basically a fine powder like flour that gets injected into a broiler or a furnace and burned. Most of that heat is lost, but what they do is they run water pipes, basically in a nutshell, through that furnace chamber, which makes that water turn into steam, which comes and turns a turbine, which generates electricity. That water that is taken and it's pulled, they can pull river water out, or you actually use a cooling tower and a cooling air system. That's what they use over in Gillette, for instance. And they cool that water back down, and that heat is released into the atmosphere or into the water supply. And then that water that's cooled back down can go back into the furnace and turn into steam again. This process just cycles over and over again, making electricity. In addition, a lot of ash is created and spent, and that goes into this location over here. This stuff is fairly toxic ash. It's high in metals and stuff, and it needs to be disposed of properly. But it does create a hazardous waste there. Coal is pretty plentiful. We have a lot of it around. We have enough to go for hundreds of years, they predict, really, if we keep at the current rate we're at. So coal reserves in the United States, Russia, and China could last hundreds of years to 1,000 years. Now, this is a really big stretch number. The biggest numbers I've seen, relatively speaking, around are 250 years at most. That's if we use it at our current rate and don't expand. But the reality is China is now using a lot of coal. They're using more coal. They're using more coal than we do at this stage. We used to use the most, but China's taking us over. And so the coal usage is going to go through the roof. Here's a breakdown of who has the most coal and where. You see Europe and Eurasia have the most, Asia and then in the Pacific Ocean, and then North America. Within North America, the country that has the most is the United States. But if you look at the greater regions, because Asia and Europe are so much larger, they end up with more coal reserves as a continent, but we have more as an individual country. So, coal is dirty. It's a problem. So there's environmental costs with burning coal. This is a picture that shows coal being burned without any pollution regulations behind it, and it creates this nasty brown smog. Actually, during the Industrial Revolution in London, this is how the sky looked all the time there. It was a very dirty time of existence for man. So, single biggest air polluter is coal countries, far and away. Of the CO2 that's in the atmosphere, a fourth of it comes from coal. In addition, it releases high levels of sulfur. In the United States, we have sulfur scrubbers that help eliminate it from coming out of the tower, but it still comes out, of course, but not as high levels as it could. That sulfur comes out as SO2, which then is used to create acid rain. There's also huge amounts of soot that are created, like if you don't have cleaning systems like this one, this brown air around you. Mercury is present in all living creatures, and so it's present in coal. And it's in a more condensed form there, and it's in high levels. So both the ash after it's burned, as well as vaporizing mercury into the air as a result of burning stuff. And then there's radioactive materials present in as well. So there's a lot of environmental issues when it comes to burning coal that we have to take into account. And so how do environmentalists want to handle it? They want to tax power companies for the amount of CO2 they put out. The more they put out, the more they get taxed. And they want to have cleaner coal burning plants. They want to increase that. Problem with that is that's a higher expense. Higher expense gets passed along to consumers, and now people are paying more for things. And so it hasn't happened on the level I think a lot of environmentalists would like to see as a result of that. Excuse my sniffles. What are the trade-offs of coal? First of all, extremely ample supplies of coal available. It has a very high energy yield. It has very low cost. It has extremely well-developed technologies. And the air pollution can be reduced drastically depending on what type of requirements we put in place for power plants. What are some bad things about it? Huge amounts of land destruction. It is a threat to human health from the burning of it if we don't take care of it. There are lots of environmental costs that aren't figured into it. There's a lot of government subsidies to help manage the coal industry. It produces lots of CO2, and then you have radioactive and toxic mercury emissions coming out of it. So, benefits, pros, and cons. That's it for coal. Come back later. Bye-bye.